Java Collections Framework list ArrayList. In this demo, I'll examine how an ArrayList behaves when adding or removing an element at the front. If you're new to this video series about the ArrayList, I suggest you watch the playlist preview and video about add an element to the end first, as a lot of basic concepts are explained there that I build upon in this demo. These are the three methods that I'll discuss. First, a 2-parameters add method which inserts the specified element at the specified index or position in a list. Second, a 1-parameter remove method which removes the element at the specified position. And finally, a clear method which removes all the elements from a list. This is the sample code. In the main method, I start by creating an ArrayList object and filling it immediately with 10 elements. Next, I'll add an integer constant 310 at position 0, completely before all the other elements. Then I remove the second element at position 1, after which I completely clear the ArrayList objects. Executing this whole program will provide following outputs. So first the 10 elements displayed, then 11 elements with the new element added all the way at the beginning. And after the remove, second element 210 is removed, so yielding 10 elements. And then finally the clear, which is not printed out afterwards. Let's find out in the memory layout what happens when executing these statements. I begin with the creation of the ArrayList object, passing 10 elements. Local variable nrs is allocated in the stack frame. The ArrayList object with instance data members, element data and size is allocated. Then 10 wrapper objects are created and an array with a default length of 10. The array is filled and the size is set to 10. And the assignment makes that nrs refers to this object at fictional address 1000. If we were to print out a content, output could look like this, so the 10 elements. Now let's add another integer constant, 310, at the first position, position 0. Before the actual add method is invoked, boxing makes that wrapper integer object holding the value of 310 is created here at fictional address 3110, and then the overloaded add method of the ArrayList class will be invoked, the add method with the 2 parameters. Let's set up the stack frame. So we have a this pointer referring to our ArrayList objects because we're calling an instance method. Then the 2 parameters, index is 0, and then the element we want to add is at reference to the integer wrapper object. Then 2 more local variables, s and element data, which are initialized in the if statement. S receives the value of size is 10, and element data receives this dot element data, so the value of 2000. So element data will refer to the internal array as well, 10 and the referral to the array. Now the if, what does it do? It checks whether s equals element data.length. S is 10, or the size, is equal to the length of the internal array, which it is. In other words, the array is full, so the grow method will be invoked. So an entirely new array will be created with a capacity of 15 elements. Element data will refer to the new array. All elements in the original array will be copied to the new array. All that happens in the grow method, and when the grow method returns, its return value is assigned to element data, so refers to the new array as well. The previous array, since not referred to by any reference variable, will eventually be cleared by the garbage collector of the Java virtual machine. I simulate this now, so I'll clear it. A slight variation of all these steps have been explained in detail in the previous demo. So if you're not really following what is happening here, have a look at the previous video. Now comes the new stuff. System.arrayCopy. We still haven't added our new element, and we want to add it all the way at the beginning at position 0. Well, this will happen in 2 steps. First, ArrayCopy is executed, and then the second statement will add the element. What does ArrayCopy do? Well, if it is invoked, it will result in the content of an array element, which represents the address of an integer wrapper object, to be copied to its neighboring element located to its right. Okay, and this is done from right to left, up to the position denoted by index +1. Okay, it is as if all the elements in the array up to that position are shifted 1 position backwards, so to the right. That's for the ArrayCopy method. After that, the new element will be added at the first position. Let's take a look. Element data, which is this one, refers to this array. Index 0 will get element, and element is 3110. So this one will be overridden and will refer to our new element. I'm just using a different color here to make it stand out more. And finally, the size is s plus 1. S is 10 plus 1 is 11, and that is assigned to size. It's an instance method, so size is not defined as local variable, so implicitly it is prefixed by this dot. So this dot is this size data member and gets the value of 11. We leave the add method, clearing up the stack frame in the process, and we're back at the main methods. And our element has been added at the first position. If you were to print out the content, a sample code could look like this. So we see 310 as first element. Let's pause here for a while and analyze this behavior. As in the previous demo, where we introduced big O notation, the time it takes for the add method to complete is dependent on the amount of elements added in the array list and the position where we add the new element. Therefore, we can express the behavior of this add method as being on, and represents the amount of elements that are stored in the ArrayList object. On expresses a linear relationship, in other words, the more data in the array, and the more the position is up front where we add the element, the longer method add will take to complete. Okay. What about remove? Let's remove the element that is located at position with index 1, so at the second position. With the add method, we saw that the content of all elements in the array up to the specified position is copied to its neighboring element located to its right. Well, with the remove we see something similar happening, but in the opposite direction. The content of all elements in the array, starting at specified position +1, is copied to its neighboring element located to its left. And the last element will receive null. It is as if all the elements in the array from that position are shifted 1 position forwards, so to the left. And finally, the size is decremented to 10. Note that wrapper object to 10 remains untouched, so to speak. So it's really the content of the array that is adjusted, not the actual object we refer to. But now, since it's not referred to by any variable anymore, it will be removed in due time by the garbage collector, and I just do it right now. The output of the ArrayList objects with the element 210 removed. Finally, clearing the array lists. Showing the GDK code right away. Setting up the stack frame. So I have the this pointer. And I have a local variable here, es, which refers to element data. So this.element data. This.element data is 4000, so es refers to the internal array located at address 4000. Some more local variables are allocated in the for loop. The 2 and the I. The 2 is initialized with a value of size, which is 10. The 2 is added, and the I will receive a value of size, but before that size will be initialized to 0. So first size will be set to 0, and then the variable of I is added to the local variables array with a value of 0. Then look at the for loop. What does it do? Well, all elements in the array will receive null. Let's do that with the first iteration. So es index I, es, this array index I, this first position will receive null. For the second iteration, I has 1, that element null, and so forth. Index 8 and index 9. So they all get null. And note as well that the wrapper objects are untouched. It is a content, and there is no shrinking of the array, so the length of the array remains untouched as well. Okay, and that's for clear. And so these objects will be cleared as well eventually. Voila. So to resume, add at a position as well as the remove and clear methods all behave in an ON fashion. Voila. I hope you have a better understanding about add, remove and clear. Thank you for watching and for liking my video or subscribing to my channel. See you.